Okay, hi class. Very good afternoon, everyone. Welcome once again to Om Institute and welcome to the session. Yes, guys, welcome once again to the Engineering Services PYQ practice session. And we had some, decent practice around control systems the other day, that is on Monday. Okay, and yeah, we practiced on Monday some areas like time response analysis, steady state errors, router widths, basic stability concepts. Okay, and now today, as I told you, control system, few more important areas are there, of course, like Bode plots and Equus plots, etc. So today we are there with the part number 2 of control system, conquering more variety of questions from the more areas. Okay, so very, very good afternoon, everyone. Good afternoon, Sai Vikas. Good afternoon, Life Man. Good afternoon, Hovand. Very good afternoon, all. Update all your friends that the session is now live. Okay, yeah, so let's start the session then. And yeah, the first important thing is, guys, 18th May is coming, and what is special about 18th May? The summer short-term course. Okay, the first summer short-term batch starts on 18th of May. Yes, guys, if you want to really enjoy the feel of offline gate preparation live in front of the faculties with the best faculty team of ECEE across the India, okay, but cannot stay in Hyderabad for a long term course. Okay, but yes, if you can manage, even if you're a college going student, you can manage to stay during the semester break of 2 months. You can enjoy the summer short term course where the first batch starts on 18th of May. Daily 7 to 8 hours of offline comfortable classes will be conducted for you. Okay, including concepts, questions, everything will be covered to you. And in this 2 months of time, approximately 50 to 60% syllabus is covered in the offline manner. What about the rest? For rest of the syllabus, you will be given the free complimentary access to the OM live courses, OM live and recorded courses, both of them. Okay, right, and that access of the online courses will be there up to your gate 26 examination. Right, so let's get started with the first question. Simple one. Okay, simple one, right? Can't be sure, Life Man, whether they will consider or not. Okay, yeah, people are raising requests, but yeah, let's wait. Only time will tell us, but we can't be sure right now because they have also gone into the same trend lines as other PSUs with respect to the age limit. Okay, so 2017 simple question, and keep answering once you get the answer. This is almost an oral question only. Our system has 14 poles and 2 zeros in the open loop transfer function. What is the slope of the highest frequency asymptote, also known as final slope, high frequency slope or final slope? High frequency slope or final slope is given by what formula? Minus 20 P minus Z decibel per decade. Okay, P is the number of open loop poles, Z is the number of open loop zeros. Okay, so what is the quantity here? I have 14 poles and I have 2 zeros, so that becomes 12 into 20, 240. So the answer should be minus 240 decibel per decade. Answer is B. Done? Yes, I because correct answer. It is the answer number B. It is the option number B. Next question. Yes, Charan Raj, correct answer, option number B. Next question. Now the low frequency asymptote has a slope of, okay, so low frequency slope, or which we also call, this is again a direct question. Okay, ESE 2018, initial slope is given by what formula? Initial slope or low frequency slope is given by minus 20 n decibel per decade, where n is the number of poles at origin, where n is the number of poles of GS at origin. So this corresponds to n equal to 2. This corresponds to n equal to 2. Okay, so it becomes minus of how much? Minus of 40. This answer is option number C. Again, a straightforward question. So yes, there can be, even in the previous session, I've shown you several questions, very straightforward, several questions conceptual. Okay, that also will come up here also in today's session, and several questions little calculative. Okay, yes, Charan Raj, correct answer. Okay, next question. Okay, 2023 ESE question, EE. Sai Vikas, correct answer C. Now you see this question, which one of the following step is correct? Correct step. Okay, while plotting an open loop Bode diagram of the open loop transfer function. Bode diagram of the open loop transfer function, which of the following step is correct? Basic understanding if you know how to sketch the Bode plot. Because usually in engineering services prelims, Okay, they will not be asking you to sketch the Bode plot. Sometimes they can, given very simple transfer function. But your reverse questions are again important. Given the Bode plot, what is the, GSHS, what is the open loop transfer function? That definitely is expected. Okay, but here they have discussed something with respect to the steps. Transfer an open loop transfer function into constant frequency form. No, the correct step is to transfer an open loop transfer function into time constant form. The correct is time constant form. If I talk first order term, okay, so into time constant form. Okay, so there is no such step involved to convert into a constant frequency form. Now for the low frequency asymptote, okay, if there is only the proportional link, one should plot a horizontal line with an amplitude value minus 20 log k. Now you see here, for the low frequency asymptote, again low frequency asymptote means initial asymptote. Okay, like initial slope I discussed in the previous question. Okay, by the time if you have read the 4 options, you should be ready with your answer. Okay, so initial asymptote, or let me call it as initial part of the Bode plot. This is a very useful formula. Initial part of the Bode plot, considering poles at origin, is given by minus 20 n log omega plus 20 log k. Okay, minus 20 n, and there can be zeros at origin. I'll write down both the cases. Okay, don't worry, I'll write down both the cases here first of all. Okay, so what is that initial part formula? It is given by minus 20 n log omega plus 20 log k if there are n number of poles, at origin, but also it may be the case that there are zeros at origin. So it is then given by plus 20 m log omega plus 20 log k when, suppose, let me call, there are m zeros at origin. Now the question says that, okay, for the initial part, low frequency asymptote, if there is only the proportional link, one should plot. Okay, so let's assume there are no poles or zeros at origin. Because initial part is a representation either of k by s square or k upon s power n poles at origin, or k s power m. Okay, considering only the proportional link also, then also what is the initial magnitude? It is not minus 20 log k, na? It should be plus 20 log k. Okay, it should be plus 20 log k. So this also does not stand to be appropriate. Option number C. For the high frequency asymptote, okay, that is the final part, one should change the slope of the asymptote in every break frequency omega t for every link. This is what is one of the most crucial step of Bode plot. While sketching Bode plot, at every corner frequency, which is also known as the break frequency, okay, which is also known as the break frequency or the corner frequency. Okay, right. So, what is the corner frequency? If there is any of the term 1 plus j omega t, 1 plus st, simple pole, or 1 upon 1 plus st, okay, the corner frequency is given by reciprocal of the time constant. I am expressing in the time constant form, right? So, yes, for the high frequency, so till you reach the high frequency asymptote, you have to change the slope, okay, of the asymptote in every corner frequency, okay, for the, for every link, for every corner frequency, okay. Compensate asymptote to get precise time constant characteristic diagram. No, nothing like that. So correct answer is option number C. Right? So language question. See, this is something about sketching the Bode plot, but I have not seen any options right now coming up in the comment box. So, okay, that is why you are also maybe taking the time to think about this. Right? Okay, so option number C stands out to be the correct answer. Right? Okay, next question then. If there is any doubt, you can specify. You can let me know if there is any doubt. Okay, 2024 ESE Engineering Services question. Have a look into it. Consider the following statements regarding the Bode plot for the type 2 system having the transfer function. So there is the type 2 system. Okay, unity feedback is given. That is why they have defined the type. Okay, gj omega k upon j omega whole square 1 plus j omega t. Okay, or if you want to, write it in the S domain, it is simply k by s square 1 plus st. The intercept of the low frequency slope, that is very correct, low frequency slope will be minus 40 decibel per decade. Now let me come to the next point here only. If the initial part is given by the formula minus 20n log omega plus 20 log k, where does the initial part, next important formula with respect to initial part, it intersects the 0 dB axis, that is x axis primarily. Okay, at what frequency? At the frequency omega equal to k raised to the power 1 by n. K raised to the power 1 by n. Right. So here, what is the value of n? For this particular question, n is equal to 2. So where does it intersect? It should intersect. Now, what is our first statement telling? The intercept of the initial slope, the initial part, okay, of slope minus 40. Why the slope is minus 40? This is correct because the slope has to be minus 20n. This is correct. N equal to 2. Okay, with the 0 dB axis occurs at a frequency omega x, where omega x should be given by k raised to the power 1 by n. N is equal to 2. So k power half root k. So omega x equal to k is wrong. Okay, so first statement is not correct. The value on the low frequency slope of minus 40 decibel per decade or its extension at the frequency omega equal to 1. Okay, so how much? See, what is that low frequency formula? Initial formula, as I told you, okay, there are poles at origin, not zeros at origin. So I will write how much? Minus 20n. Minus 20n becomes minus 40. So minus 40 log omega plus 20 log k. Minus 40 log omega plus 20 log k. That is what is the initial part formula. Okay, they are telling the value on this initial part, okay, at frequency omega equal to 1. Okay, so even if you put omega equal to 1, log 1 is 0, magnitude becomes still 20 log k, na? Log 1 is 0. But is it 40 log k? No, the second is also not right. Okay, then next, the gain k is the static ramp error coefficient. Okay, it's a type 2 system. Okay, is it the static ramp error coefficient? See, it's a type 2 system. Okay, it's a type 2 system. Okay, now, if it is a type 2 system, the steady state error for step as well as ramp, they mentioned ramp, na? Okay, because it is type 2 system, the steady state error for step as well as ramp, for both of them it will be 0. Okay, and the Kp tends to infinity, the Kv. Okay, the ramp error coefficient is Kv, velocity error coefficient. Both of them tend to be infinity. Okay, only thing is this K will be equal to, because it is time constant form, the acceleration error coefficient will be K and steady state error will be 1 upon K. Okay, this steady state error will be for parabolic input. Unit parabolic input, for which we find acceleration error coefficient. So this also is not correct. This also it's not correct. Okay, right, this also is not correct. Right, so first is also not correct. Okay, first is also not correct, second also not correct, third also not correct, and they are asking which of the above statement is or are not correct. So all the three are not correct. The problem with the question. So even in the last session we saw there are some errors with the options. Okay, that happens sometimes in engineering services. Any comments from your side? No. Charan Raj says B. B means 1 and 2. You are considering 3 correct. No, the gain K is not the static ramp error coefficient. It is the parabolic, because it is type 2. It could have been the answer if it was type 1 system. Okay, so let me recheck the option. The intercept at 0 dB should occur at omega equal to k power 1 by n, which is not correct here. They have only mentioned k, or if this is a typing error, I don't know. So as of now, 1, 2, 3, all are not correct. Okay, the not correct statements are 1, 2 and 3. Clear, everybody? Any doubt, please specify. The not correct statements are 1, 2, 3. All are not correct. All are not correct here. Okay. All are not correct here. Okay. Let's move to the next then. Okay, let's move to the next. Type 2 system. Yeah, rest all is okay only. Yeah. minus 40 log omega plus 20 minus 20 n log omega plus 20 log k. That is also correct. So it should not be 40 log k. Yeah, all okay only. Okay, so 1, 2, 3, all are not correct. Okay, simple question 2021. A simple question 2021. Okay, let me know the answer for this. Okay, the transfer function of the system GS is 1000 upon 1 plus 0.1 s 1 plus 0.001 s. What are the corner frequency? Oh, direct time constant form is given. Okay, direct time constant form is given. One of the corner frequency, see, I told you for any of the term 1 plus st or 1 upon 1 plus st, okay, the corner frequency for both of them is 1 by t. Or if, see, this is time constant form. If it is given, non time constant, s plus a form, s plus a, or pole term 1 upon s plus a, then the corner frequency is a. You can convert to time constant, or you can directly say the corner frequency there will be a. Okay, so here the first one is 1 upon time constant, that is equal to 10, and the omega 2 will be 1 upon the another time constant 0.001. So this becomes how much? This becomes the 1000. This becomes the 1000. Okay, so it is how much? 10 and 1000. Option number D. 10 and 1000. Yes, Charan Raj and Sai Vikas, correct answer. Correct answer is option number D. Simple one. Okay. Next question. The open loop transfer function. Okay, given the Bode plot, what is the open loop transfer function? Come on. Okay, so this also, now this forms a very expected question given the Bode plot, and you have to get the GSHS. Right? Yes, Bhargav Das, tell me. Okay, so see now, first of all, look into the initial part. Okay, the initial part is having how much slope? Minus 40. Okay, whereas it should be having the slope minus 20n. That means what is the value of n? N is 2. Okay, 2 poles at origin. Okay, 2 poles at origin. Okay, 2 poles at origin. So definitely 2 poles at origin means either A or C. Okay, either A or C. Now, this is a corner frequency. Now, the slope changes minus 40 to minus 60. That means slope decreased. Okay, slope decreased by minus 20. So, this is the corner frequency of pole. Now, from minus 60 to minus 40. So, slope increases this time. From minus 60 to minus 40 line, the slope increases by plus 20. And if the slope increases, this should be a 0 term. 0 should fit in the numerator. Okay, 0 should fit in the numerator. All are non-time constant forms. But okay, but if it is non-time constant form, I told you, no? Okay, s plus a or 1 upon s plus a, then the corner frequency is a. Here the corner frequency is visible to me. Okay, 5 and 10, but this should be numerator, s plus 10 upon s plus 5, and denominator should have s square. Denominator should have the s square. Okay, so s plus 10 in the numerator divided by s plus 5 in the denominator and a s square. Correct. Option number C. Option number C. Yes, Sai Vikas and Charan Raj. So you don't have to solve it fully also. Just observation you can comment, na? Okay, just observation you can comment. Okay, right. So this contributes to the 0 term s plus 10. This contributes to the pole term s plus 5. Okay, s plus 5. Right, and 2 means these are the number of poles at origin. So there should be a s square in the denominator. Okay, some constant k, they don't ask. See, because to find k, again some additional data should be given. That also they can give in us, but not required. They have written all the answers in k. Okay, in the format of k. Ocha, one more thing let me tell you. When I'm using this formula, na, I told you these are important formula, can help you in many questions. But when I'm using this formula, okay, magnitude minus 20 and log omega plus 20 log k for the initial part, this k is the gain k. Okay, this gain k is the gain, okay, in the standard form, in the time constant form. When the, GSHS should be in the time constant. Okay, time constant standard form. Okay, time constant standard form, right? Okay, so this was done. C option. Next question. Okay, again they don't want the value of k. Which one of the following transfer function represents the Bode plot? Okay, Bode plot. Now see again, now you see initial slope is positive. Initial slope positive, 40 plus 40. So this should be equal to, this 40 should be equal to plus 20m. Positive initial slope means zeros at origin. Okay, then there are zeros at origin. How many? 2, but this time zeros, not the poles. Zeros at origin. Very clearly, only one time slope change. Okay, so only one corner frequency. How much is the slope change? 42 minus 60. How will you go 42 minus 60? It's a change of 100. 40 minus 100 will give you, okay, minus 60, and minus 100 means at this location, okay, at every pole slope changes by minus 20. But if there is a slope change of minus 100, it should represent 5 poles. It should represent 5 poles. It should be representing the 5 poles, correct? It should be representing the 5 poles. Okay, 5 poles. Okay, so 5 poles means there should be a s plus 10, okay, power 5 in the denominator, okay, or they have written in a time constant form. Okay, so 5 poles. So what is the corner frequency? Corner frequency is 10. So what should be the time constant? 1 by 10. They have written in the time constant form. So 1 plus s by 10 whole power 5, okay, and numerator ks square. Option number C. Option number C. Yeah, correct answer, Charan Raj and Sai Vikas. Correct answer. It is option number C. Okay. It is option number C. Next question. Okay, next question. Okay. Again, conceptual one, the 2017, the previous one was 2018. Now, there are two statements and we have to say which of them is correct and whether the second is the correct explanation of statement 1 and all. First, let's read that and then we'll go to the option. Okay, right. Let me read. Let me uplift this slightly. Yeah. So, what is there in the statement number 1? Roots of closed loop control systems can be obtained from the Bode plots. Okay, roots of closed loop control system can be obtained. No, from the Bode plot. Bode plot we usually see. Normally, Bode plot is drawn for what? Open loop transfer function, GSHS. Okay, by corner frequencies, like in the by examining the initial part and the corner frequencies, you are able to say how many poles and zeros are there, how many at origin, how many at other. Okay, but they are the poles and zeros of open loop transfer function. Okay, so this Bode plot will give the information of open loop transfer function. Then from open loop transfer function, you can form characteristic equation and comment on roots of characteristic equation by some other methods like Routh-Hurwitz or etc. But can the roots of closed loop transfer function directly obtained from Bode plot? No. Okay, no. So this is not correct. Okay. Nyquist criteria does not give direct value of corner frequency. A Nyquist plot does not depend, on Nyquist plot sketching directly does not involve any corner frequencies. Procedure for sketching Nyquist plot is something else. Okay, we take the 0 and infinity, the two important points, the starting and ending frequency, and some intermediate critical frequency where the Nyquist plot cuts any axis. Okay, but we don't use any corner frequency to draw Nyquist plot, and hence any Nyquist plot cannot give you the direct value of the corner frequency. So does not give you, yes, they have mentioned correct. Okay, so correct answer is then option number D only. Okay, correct answer is option number D. Charan Raj, correct answer. So correct answer is D. Yes, statement 1 is false, but the statement number 2 is true. Statement number 2 is true. Right, D is the very correct answer. Okay, next question then. Right. Again, similar, concept and the examination of the given statements. Okay, so what is there in this question? What is there in this question? Okay, statement number 1, the transportation lag in a system. Now, first of all, you should know what do you mean by a transportation lag. Okay, they have given the hint e power minus st, but you should know that transportation lag or also known as the time delay element, very commonly known as the time delay element, e power minus st, e power minus std. Okay, where TD is the amount of delay. Okay, this e power minus st, which is responsible, okay, for bringing the delay in the system, okay, is known as the time delay element or transportation lag. Okay, which brings a transportation lag in in the output as compared to the input. Okay, this can be handled easily using Bode plot. Yes, this is correct statement. Why? Because whenever you take e power minus std, the reason, now look into the reason. Okay, whenever you take e power minus std, let me write down here. Okay, so e power minus j omega td, let me put it this way, converting to the frequency domain. Okay, when you convert to the magnitude and phase, see, what is the magnitude of this? Nothing, 1. What is the magnitude of this? Nothing, 1, because mod of e power j theta is 1. Okay, but what is the phase of this? E power j theta, theta is the phase. So what is the theta here? minus omega TD. Okay, but when you convert to the decibel, the absolute magnitude is 1. Okay, but when you convert to the, once we go to Bode plot, we need in the decibel scale, logarithm scale, this becomes 0 dB, and hence Bode plot is unaffected. The Bode magnitude plot is unaffected. Only there is a shift in the phase plot. The magnitude plot is unaffected and the phase plot shifts by minus omega t due to the presence of e power minus st. Okay, I think this is a typo error. This also has to be minus s capital T. Okay, so the first and second statements both are correct here, and second is actually the correct reason, the very correct reason why the time delay element is better handled using a Bode plot. Again, when you have studied control system, all these points are a part of your notes. That is why last class also I told you, for engineering services prelims in control system, completely first revise all your notes, okay, whether you have the notes made for GATE or any exam preparation, and then solve the questions. There can be from control system numeric questions or direct conceptual question. So 1 and 2 both are correct, and statement 2 is actually the correct explanation. Sometimes they give the question where both statements are correct but they are independent. Statement 2 does not make a reason, is not a reason for the statement number 1, but here statement number 2 is the correct reason that why transportation lag is better handled using the Bode plots, not by the Nyquist plots. Because if you take the polar plot of e power minus std, why it is not much appropriate by polar plot, because polar plot takes a spiral shape, okay, cutting the negative real axis multiple times, right? Whenever this term is involved, the polar plot will be having spiral shape. Okay, next. Okay, again 2024 question. Okay, again on statements. Basic definitions of gain margin or crossover frequencies or phase margin. Let's read one by one. Gain margin is used to indicate the proximity of the intersection of the negative real axis made by polar plot, okay, to the -1 plus j point. This goes false. Okay, gain margin is definitely used to indicate the proximity of the intersection of negative real axis made by polar plot to which point? Okay, this is actually wrong here. Actually, it is, okay, proximity to which point? -1 plus j0. -1 plus j0, not -1 plus j. Correct? Not -1 plus j. They have given -1 plus j. The phase crossover point is the point in the gj omega plane at which the polar plot intersects the positive real axis. No, phase crossover frequency is the frequency at which polar plot cuts the negative real axis. Okay, this has to be the negative real axis, dear. Okay, so this is wrong. Okay, then the phase crossover frequency is the frequency at the phase crossover point or where the angle gj omega hj omega 180 degree. Perfectly correct. Why? Because as I told you, okay, the phase crossover frequency is the frequency at which the polar plot cuts the negative real axis, and for negative real axis, okay, what is the angle gj omega? What is the phase for any negative real number? Okay, it is plus or minus 180, both are equivalent. Whether plus 180, minus 180, both are equivalent. Correct, na? Okay, so this is a correct statement. And again, they are asking which of the statements are not correct, is or are not correct. So 1 and 2 are not correct. I will mark option number B. I will mark the option number B. Right, so this has to be negative real axis for correct statement. In the first statement, it has to be -1 plus j0. Okay, but it was -1 plus j, so that is the wrong. Okay, everybody. Okay, so B option. Yes, Charan Raj and Sai Vikas correct. It is the B answer here. Next question. Okay, for an unstable feedback system, the gain margin is the negative or the phase margin is the positive. See, and for stable system, I don't know what is written, but for any stable system, both gain margin and phase margin are positive. Okay, phase margin in degrees in the standard units, of course, and gain margin in decibels. Okay, and similarly for unstable system, both will be negative. It's not one positive, one negative. That will not happen. Both gain margin and phase margin are negative for unstable system. Again, the units being, gain margin in decibel, phase margin being in degrees, right? Okay, so the first is wrong, and for stable they say both are positive. Correct. This is correct. This is wrong. For statement 1 is false. Statement 2 is true. Option number D. Simple question. Simple question. Again, something that you should directly know. Something D. Yeah, correct. Charan Raj correct. Sai Vikas, it's not C. It has to be D. It has to be D. Okay. Okay, yeah, correct. Next question then. The phase margin, oh, direct question of phase margin. The phase margin of the system having the loop transfer function GSHS equal to 2 root 3 upon S, S plus 1. 2 root 3 upon S, S plus 1. Let's check it out. 2 root 3 upon S, S plus 1. Okay, the phase margin of such a system. Okay, the phase margin of, for phase margin, we need the gain crossover frequency first. Let me convert this to the omega domain. Gj omega Hj omega is equal to 2 root 3 upon j omega into 1 plus j omega. 2 root 3 by j omega, 1 plus j omega. Okay, now phase margin is calculated, is calculated at omega g. Okay, what is omega g? Okay, at which the magnitude of the system is 1. Okay, at omega g, okay, the mod gj omega g, Hj omega g equal to 1. That means 2 root 3 divided by j omega magnitude omega at omega g. I will substitute omega g. 1 plus j omega magnitude under root 1 plus omega square, under root x square plus y square. This should be 1. Okay, shifting this denominator right side and take the square. So 2 root 3 square 12 equal to omega g square, and this under root will cancel 1 plus omega g square. And then we know to solve this normally, okay, we will take omega g square equal to x. Okay, equal to x. So you will get the equation 12 equal to x plus x square. Okay, or rather I'll write this as the quadratic equation finally, x square plus x and then minus 12 equal to 0. X plus 4, x minus 3. So x equal to minus 4 and plus 3. X equal to minus 4 and plus 3. Okay, but yeah, what is the value of x? What is the value of x? Okay, omega g square. Okay, which cannot be negative because omega, the gain crossover frequency, is a real term. Okay, so this is x which is equal to, this is x which is omega g square. Okay, which cannot be negative. So what is omega g square is 3. Okay, so what is omega g? Let me write omega g directly. Omega g is root 3. Okay, omega g is root 3. Now, what is the phase margin then? What is the phase margin? Okay, Sai Vikas and Charan Raj has the answers already. Now, phase margin is given by 180 degree plus angle gj omega g at j omega g. 180 plus phase at the omega g. Okay, so 180 degree plus what is going to be the phase part? Now you see, numerator is positive real number. For denominator, we subtract. Okay, how much is the first term in denominator? Pure imaginary, so 90 degree. Again, denominator term means minus phase. 1 plus j omega. So phase is tan inverse omega by 1. Which omega? This omega has to be root 3. Okay, so 180 minus 90 and minus tan inverse root 3, 60. Okay, so net answer left is 30 degree then. Net answer left is 30 degree. It is root 3 coming up now. Yes. So 180 minus 90 is 90. 90 minus 60, 30. It is C answer. Correct. It is not A. It is the C answer. Okay. Yeah. So I think you earlier written A. No, it is C answer correctly. It is the C answer. Sai Vikas. Correct now. It is C answer. Okay. Simple question, but be careful in the calculations or no hurry burry error. Nanendra correct answer. It is 30. Okay, next question then. Sometimes see, they ask very simple question. For the given transfer function, what is the phase of the frequency response? See, if you convert to the frequency domain gj omega, it is k upon 1 plus j omega t. And what is the phase? Phase means angle gj omega g. Direct question. Formula. Fundamental. Okay, the numerator is positive real number 0. Denominator is, denominator is minus tan inverse omega t. Denominator will have the phase minus tan inverse omega t by 1. Tan inverse y by x, which can also be written as tan inverse minus omega t by 1. Okay, or tan inverse means arctan. So tan inverse minus t over. Okay, 1 plus st and s equal to j omega. Omega has to be there, but okay, no problem. They have missed writing it. So option number A. That nature is very clear to us. Option number A. Okay, it should be arctan minus omega t. Tan inverse means arctan function. We also call it as the arctan function. No? So option number A. So just a formula, okay? Just a formula. Abhi. Okay, next question. Right, 2018, have a look into this. The open loop transfer function of a system has two poles on imaginary axis, one in the left half, another in the right half, together with a zero at the origin of coordinates and also two zeros in the left half of the S-plane. The closed loop response for unity feedback will be stable if the encirclement of the critical point is how much? If the encirclement of the critical point is how much? See, for the closed loop system. So now this is about encirclements of -1 comma j0. That talks about the Nyquist plot. The encirclement is given by the formula p minus z. Okay, assuming clockwise Nyquist contour. That is not mentioned. So I will assume, okay, the clockwise Nyquist contour, the clockwise Nyquist path, because they have not mentioned anything about the Nyquist contour. So let me take it as clockwise as a regular rule. Okay, as a regular convention, no theorem or no logic behind this, as a convention, I will say. Okay, so n equal to p minus z. Now p plus is what? The n is the number of encirclement. What is p plus? Okay, what is p plus? Okay, n is that number of encirclement of -1, 0. Okay, p plus, okay, are the poles, number of, okay, poles of open loop transfer function, okay, in the RHP. Okay, plus I denote to, always make you remind that it is the poles in the right side, okay, positive side, okay, that is why RHP, and that is clearly mentioned. See, there is a lot of data about open loop transfer function mentioned in the beginning, okay, has two poles and imaginary, one in the left and the other in right half, very clearly mentioned, p plus equal to 1. Okay, now come to z plus. What is z plus? Z plus is the number of zeros. Okay, number of zeros of what? Of the open loop transfer function? No, number of zeros of 1 plus GSHS, not GSHS, okay, in the RHP. And the zeros or roots of 1 plus GSHS is basically the roots of characteristic equation. This is basically roots of characteristic equation in RHP. How many are the roots of characteristic equation in RHP? Now, you want the system to be stable. For stable system, there should not be any root in the RHP, correct? Na? So for stable system, Z plus must be 0. So what is the number of encirclement you want? Which is equal to 1, which is equal to plus 1. Sign convention again, plus 1 for anti-clockwise encirclement, -1 for clockwise encirclement. Yes, B is the correct answer. Yes, Sai Vikas. It's a basic, reading question. I just have written some definitions for your revision, but it's an oral question where you can say, okay, n is p minus z, and p is directly mentioned. There is other one pole in the right half plane. Z plus has to be 0 because you want stability, because you wanted stability. Correct. So direct question, I would say, direct question. Okay. Now the direction of the net encirclement of the origin of real imaginary plane in a Nyquist plot for the system to be stable is. Now you see, for the system to be stable, again what you want, z plus equal to 0. Okay, and then again assuming nothing mentioned, if I assume clockwise Nyquist path, okay, so what is the n? Is p plus minus z plus, but for stability, the number of encirclement should be equal to p plus. For stability, z plus has to be 0. Okay, now what is the direction of net encirclement? Now see, n is p plus. Again, this is on assumption. On clockwise Nyquist path, they should see, when it is gate questions, they will be very careful in giving the data. They mostly tell you about the Nyquist contour, or directly, indirectly they mention about Nyquist contour. Here they are not mentioning, so I am going by a by default rule assuming clockwise. Otherwise, answer for previous will also change. If it is anti-clockwise Nyquist contour, answer becomes -1, because for anti-clockwise Nyquist contour, answer is z minus p. So these questions are debatable, but okay. Don't spend your time or don't debate anything in engineering services. Take a rule. Take clockwise Nyquist contour as a standard rule. Okay, convention. No theorem. It is not that you have to take it hence prove, but as a convention you can take it. Okay, so similarly here I am assuming clockwise Nyquist contour. Otherwise the answer becomes z minus p. But okay, here it is n equal to p plus. Now what is p plus? As I revised already, number of poles of GSHS in RHP. How many poles of GSHS in RHP? Not given, but it may be 1, 2, 3 or nil. That's what. Okay, so number, it's a count of number of poles. So it cannot be at least -1 or -2 or etc. Na? Okay, so n equal to p plus, and p plus could be 0, 1, 2. It's a count, na, etc. Okay, that means n, the number, they're asking now the direction of net encirclement. Now, n is going to be, this is telling you that n is greater than or equal to 0. Maybe 0 means no encirclement, but if there is an encirclement, it looks like a n being positive value, and n equal to positive means anti-clockwise encirclement. Anti-clockwise, counterclockwise, okay, counterclockwise. That too, it is the encirclement of which origin? Origin of the, it should be actually with the clear data, origin of the 1 plus GSHS plane. Okay. Because if you talk about GSHS plane, then it is about the encirclement of -1, 0, -1, 0. But okay, we can make out what they are asking and we can choose the option. Although the question is not 100% conceptually complete, but we can mark out there what they are expecting, what they are, maybe what their feelings were while making the question. You understand those feelings and mark the answer. Okay. Again, I am telling 100% it is not a conceptually complete question. Okay. But okay, we can mark the option. We can mark, we can satisfy the answer. Okay. Any doubts you can ask me. If there is any doubt, you can ask me. 2022 question. ESE 2022 question. Consider the closed loop system shown in the figure. What is the critical value of K for stability? Okay, now again incomplete question. Again incomplete question, because as per the Nyquist stability criteria, what is N is given by P plus minus Z plus. N is given by P plus minus Z plus, right? Okay, where is P plus? Not given, na? Not given. Okay, you want stability. Okay, you want stability, so you can take Z plus 0. You can take Z plus 0. Okay, so N becomes again equal to P plus, and there is no data about P plus, so we will assume, again we will have to do an assumption to complete the question. Okay, what is the assumption? Assume that open loop transfer function is stable. Okay, open loop, now any transfer function is stable means that particular transfer function will not have RHP poles. P plus will be 0. So you have to take n equal to 0. N equal to 0 means no encirclement. No encirclement of what? -1 plus 0. -1, 0. Okay. So now in this there are two situations. Now see, this is there is a circular polar plot given to you, Nyquist plot given to you, center minus k by 2, radius k by 2. Okay. So this is definitely origin, and this becomes minus k by 2, minus k by 2. What is this point equal to then? This point is minus k, 0. So now there are two possibilities. Where is -1, 0? Maybe outside, or maybe inside. Okay, maybe outside, maybe inside. Case number 1, case number 2. But in the case number 1, there is no encirclement. That is what you want. But in the case number 2, there will be an encirclement. There will be an encirclement. Okay, and that encirclement is how much? 1 in the anti-clockwise direction. There is 1 anti-clockwise. That means positive 1. Anti-clockwise encirclement means positive 1. Okay. N equal to 1. Okay, but I want n equal to 0 for stability. I want n equal to 0 for stability. So 1 I don't want. So this will be happening if -1 is outside. That means this point 1 in magnitude of this point. This distance is 1. This distance is k. Okay, so k should be less than 1. Critical value. Okay, critical value equal to 1. The critical boundary value. Okay, for pure stability it has to be less than 1. K greater than 1 unstable. Okay, k greater than 1 unstable. Okay, k equal to 1 will be the boundary value, critical value, because with n equal to 1, the system will become unstable. Okay, so answer is C. Hope you have made out the answer. Yeah, it is C. Correct. Right. No, not for k greater than 2, sir, because there is no option with respect to 2 also. Why? Because you see, minus k by 2, this becomes minus k. That radius is given. So it has to be compared with 1 only. Okay. It has to be compared with 1 only. K greater than 1. Correct, na? Tell me the doubt, Sai Vikas. See, now this is minus k by 2. This is only center, and still radius is k by 2. So how much is this point? Minus k, 0, na? Minus k, 0. Okay. Right. So you can, you can treat the problem in the reverse way also. You can treat the problem in the reverse way also. Okay. So what happens? Okay. Let me write this way. This was my first case when -1, 0 outside. So if I take first case, what is the number of encirclement? Is 0. Okay, and if number of encirclement is 0, so n is equal to p plus minus z plus. I assumed p plus 0. As I told you, there is no other choice. So z plus equal to 0. This is what you want for stability. Okay, case number 2. Case number 2 means there is clearly one anti-clockwise encirclement. So n equal to plus 1 equal to p plus minus z plus. So as I told you, okay, again p plus has to be 0. Okay, so what is the value of z plus? Okay, so now this case again is at fault only. Okay, so yeah, so okay, no problem. For that you will have to assume clockwise. Actually, it has to be anti-clockwise Nyquist contour problem. Okay, right. Right. So let's not go into that. Okay, I'll only take this condition, and z plus equal to 0 means system is stable. Z plus equal to 0 means the system could be stable. Okay, so for stable condition, this is possible n equal to 0 if 1 is less than k. Sorry, if k is less than 1. If k is less than the 1. Okay, so boundary value k equal to 1. Okay, boundary value k equal to 1. Okay, the boundary value k is equal to 1. This is anti-clockwise. Okay. Okay, now here I will explain you. Okay, let me go some deep inside the question. Okay, concept is important. Okay, so let me go deep inside the question, and what will I do? I have again first and second cases, remove everything. Answer is k equal to 1. That is very logically understood. Okay, now let's go deep inside the question. Okay, nothing is given about p plus. Okay, so we'll assume open loop transfer function as stable. Okay, that I will assume. So we will take p plus equal to 0. Now you see, okay, now you see if the point minus 1 comma 0 was inside by chance. Okay, let me take this as the first case. Now going deep inside the question. Okay, okay, going deep inside the question. So as per the case number 1, okay, this particular distance is 1, and this particular distance, again I'll write down, this point is minus k comma 0. Hope that is clear. So 1 is less than k or k greater than 1. For k greater than 1, what is the value? N equal to plus 1. There is one clear anti-clockwise encirclement. Okay, there is one clear anti-clockwise encirclement, right? Now there is clear one anti-clockwise encirclement. Okay, so now dear, if you apply p plus minus z plus, okay, if you apply p plus minus z plus, okay, p plus minus z plus. First of all, again, this language of the question is also not correct. Consider the closed loop system. The Nyquist plot is the Nyquist plot of the open loop transfer function. Okay, everything here in the question is wrong. They have made so many blunders in making the question. Conceptually, I have shown you with the previous question also. Okay, but okay, this is the Nyquist plot of open loop transfer function. Okay, this is definitely the Nyquist plot of open loop transfer function. That is what we will assume. Okay, otherwise the story will itself change. I told you assume p plus equal to 0. N equal to 0 minus z plus. So what is z plus equal to minus 1? Not possible. I told you, like p plus or z plus, this is count. Z plus is number of zeros of 1 plus GSHS in the RHP. So that number could be minimum 0 or 1 or 2. What is that? Minus 1 zeros. No. Okay. So this is negative, means not possible. Okay. So this time here you will try the formula z minus p. Okay. Assuming what? Anti-clockwise Nyquist path. Assuming anti-clockwise Nyquist path. Okay, so n equal to z plus minus p plus, n is 1 equal to z plus minus 0, so z plus equal to 1. Okay, unstable, yes. Okay, but why I have gone deep inside the question? So that I will tell you that for this particular question, z minus p is the formula applicable. Answer will be 1 only. I told you logically answer is 1. Okay, but just we should be very clear about the concept. Okay, now second story. Now second condition is the condition where I will take minus 1 comma 0 outside. Okay, minus 1 comma 0 outside, and that is possible if this k is less than this much of the distance 1, for k less than 1. Okay, what formula to be used? N equal to z plus minus p plus. What is the n? N is now 0. This is outside the Nyquist plot, no encirclement. Is z plus minus p plus assumed to be 0, so z plus is 0. System is now stable. So for what value it is stable? For k less than 1 it is stable. Boundary value will be k equal to 1. Okay, this is the correct concept. This is the correct concept. So what is the formula for this question? Is z minus p. Is z minus p. Okay. But again, all this was an assumption with p plus equal to 0. This is an incomplete question, I would again say. Let's go to the next question then. Consider the closed loop system. Where is the closed loop system? They should mention that consider the Nyquist plot for the system shown below. Okay, so there are a lot of blunders in making these questions, but no problem. Let's go to a next question now. Let's go to a next question now. Yeah, come up to this and answer. Now, state space analysis in engineering services for EE is actually very frequent. For EC, I will say moderate frequency. In GATE, it is actually reverse. In GATE, state space analysis is very important for EC, moderately important for EE. It is important for EE also, but for EC, it is more important. In GATE, in engineering services, for EE, it is more important. State space analysis. For EC, moderately important. This is how I will say. State transition matrix, direct question. What is the state transition matrix? State transition matrix, which we also call it as phi t, is e power at. And how do we calculate? Okay, it is calculated as inverse Laplace transform of Si minus a whole inverse, where this particular term Si minus a whole inverse is then known as the Laplace transform of phi t. Okay, and we represent it by phi s. Okay, where A matrix is given to us. Okay, so let's start working on the state transition matrix. Okay, yeah, so let's start solving. Okay, the A matrix is given as 1 0 1 1, correct? Yeah, so now what is going to be Si minus A? So Si is S0 0 S into identity minus A matrix. Subtracting them, I get S minus 1, 0 minus 0, 0 minus 1, and again S minus 1. Okay, this is what it is, right? So now I need to create first inverse of this matrix. What is the formula for inverse? Adjoint upon determinant. So adjoint Si minus A divided by the determinant of Si minus A. Divided by the determinant of Si minus A, right? So what is the adjoint? For 2 cross 2 matrix, now adjoint is very simple. Just exchange the diagonal numbers, which are by chance same here, but whatever diagonal numbers we will exchange, and for off diagonal numbers change the sign. So minus 0 is 0, minus 1 will become plus 1. Okay, for 2 cross 2, otherwise for adjoint we will calculate cofactors and all, but for 2 cross 2 what is the adjoint? Remember, for 2 cross 2 what is the adjoint? Just exchange the diagonal numbers, and for off diagonal numbers just change the sign. Okay, just change the sign, very simple. Divided now by the determinant, and determinant of this is S minus 1 whole square minus 0. Okay, now this will be divided with every element. So first is 1 upon S minus 1, then 0, then third is 1 upon S minus 1 square, and then again 1 upon S minus 1, right? Right. Now, what is going to be the state transition matrix? As I told you, it is the this is the phi s term, Laplace transform of state transition matrix. The state transition matrix is the inverse Laplace of this term, Si minus A whole inverse, and then this is equal to inverse Laplace 1 upon S minus A. What are the important Laplace transform formula you will use here? E power minus at, or this should be e power plus at. E power plus at Laplace 1 upon S minus A. T e power at Laplace formula 1 upon S minus A whole square, right? So what are the formulas? E power plus 1t, then 0, t e power t, and then again e power t, e power 1 into t. Okay, this is the state transition matrix. That is option number C. The correct answer is option number C. Okay, the correct answer is option number C. Okay, now I'll tell you a simple method. This is a detailed method. Okay, this is a detailed method. Okay, now a shortcut method. Always remember, it will work in some of the questions. Always remember that state transition matrix phi of 0. Okay, there are 2 points to be noted. Phi of 0. Okay, e power at. Okay, when you put t equal to 0, it will always become identity matrix. E power 0 identity matrix. Okay, and second point, okay, phi inverse t, the inverse of the matrix, will always satisfy phi of minus t. But you know, phi 0 should be identity, na? Phi 0 should be identity. When you put t equal to 0, okay, in this option, this becomes 0. Now, identity means what? Identity looks like how much? What is identity matrix? This is identity matrix for you, na? So you put t equal to 0, here you get 0. This cannot be identity. This is already 0. This cannot be identity matrix. You put t equal to 0, this is also 0. Okay, you put t equal to 0 here. E power 0, 1, 1. T equal to 0 here, 0. So 1, 0, 0, 1, identity matrix. Only and only option number C. Correct? Only and only option number C. At t equal to 0, okay, if you match the state transition matrix, only option number C, okay, will satisfy. State transition matrix anytime at t equal to 0, okay, if you check, it should be identity matrix. Correct? It should be identity matrix. So, simple method, shortcut. Otherwise, if this does not work, it may not work with every question. Okay, so then, okay, this is the method. This is the complete method. Next question. The transfer function of a discrete time system derived from the state model is given by what formula? Okay, it is given by the formula C phi s b plus d. Direct formula question. C phi s b plus d. What is phi s? Phi s, as I just explained you, Laplace transform of state transition matrix, Si minus A whole inverse. Option number A, C phi b plus d. Option number A, direct question. Option number A, direct question. Yes, I Vikas. Okay, option number A. Next question. Okay, now given the state space model x dot equal to ax plus bu, y equal to cx, what is the transfer function? Now see, let's talk about some more techniques. See, if this is the transfer function given, okay, to solve this there are two methods. Okay, method number one, the formula I told you, transfer function equal to C phi s into b plus d. Okay, where C is given, B is given, phi s you will calculate with the help of A matrix, and then D is null here. Okay, that calculation has to be done. Yes, Charan Raj, correct answer for the previous one. That is the first method. Method number two, if you identify the state space model, there are four important state space models in the standard forms, in the canonical forms, which you must all remember. Okay, if you really want to solve questions of, state space analysis quickly, you should remember these formats, and the formats are CCF, OCF, DCF, JCF. Controllable canonical form CCF, observable canonical form OCF, diagonal canonical form DCF, Jordan canonical form JCF. And yes, this is directly 0, 1 minus A0 minus A1. This is directly the CCF model given. Okay, CCF model given. So what is my transfer function? My transfer function will be equal to B. Now, if you want to learn more about CCF, OCF, and if you have never learned about this earlier, you can watch my earlier videos on state space analysis, concept videos. Here I will just write down the answer, because if I have to explain you CCF, OCF, DCF, JCF, that itself is another another concept. Okay, that will take easily 1 or 2 hours only to talk about the standard models. So B, okay, into, now we call this as B. Okay, we call this as 0, 1. What is the standard CCF model? Okay, that at least I'll write down for you. What is the standard CCF model? X dot equal to 0, 1 minus A0 minus A1, okay, into X plus 0B into U, and Y equal to C0 C1X. Okay, C0 C1X, and the transfer function is given by B into C1S plus C0. This is B and this is C0 C1. C0 constant, C1 is the coefficient of S, divided by S square. Now, denominator is built using this matrix. Okay, write down the elements, this minus A0 at the last, plus A0 with the sign change actually. Okay, this is constant, then go reverse. Okay, then A1S again with the sign change. Okay, so as per this data, B is equal to 1 here. Okay, C1 is 0. Okay, so 0 into S plus C0, C0 is 10 divided by S square. Now, this is the constant term. Minus 3 means here it will come plus 3, then plus 4S and plus S square. So answer has to be 10 upon S square plus 4S plus 3, option number B. Option number B. Okay, option number B, right? Correct answer, Sai Vikas. It is option number B. Yes, Ajay, we'll have signals PYQs also in this ESE. Probably next time planning, 1 or 2 sessions on maths. Okay, that is also important, because maths is there in paper 1, the GS paper, and for EE student, maths is there in the paper 2 also, technical portion also. The next probably I'm planning maths and then signals. Okay. But yeah, in the upcoming, few days, we'll cover both. We'll cover both. Right. Let's go to the next question then. Let's go to the next question. The state equation and the output equation of system are as follows. X dot equal to ax plus bu, y equal to cx. Okay, x is the state variable, u is the input variable, y is the output variable. What is the number of right half plane poles? Now see, okay, right half plane poles. Now poles are normally what? Roots of characteristic equation of the system. Okay, but characteristic equation of system, okay, roots of characteristic equation of system are also equal to the eigenvalues of this system matrix, which is A, and characteristic equation of system is identical to the characteristic equation of the matrix A. Okay, characteristic equation of the matrix A. Correct, na? Correct. That is some principles you must know. Now, what is the characteristic equation of this matrix? 3 cross 3 matrix. Simple way to write the characteristic equation as you learn in mathematics. Okay, it is given by lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 equal to 0. Right. What is the beta 1? Is known as the trace. The beta 1 is 0 plus 6 plus 9, sum of diagonal elements 15. What is beta 2? Beta 2 is known as sum of minors of the diagonal elements. First diagonal element, okay, the minor will become 6, 9, 54 minus 9, 3, 27. Okay, so 54 minus 27 plus sum of minors of all diagonal element. So this is the second diagonal element. If you don't know, you can write. I'm dictating, that is why. What is beta 2? Sum of minors of diagonal element. The second diagonal element, I've deleted second row, second column, then 0 minus 10. That is the corresponding minor. And plus, okay, this is 9, third row, third column deleted, then this is 0 minus 5. Then this is 0 and minus 5. So total it becomes how much? 27 minus 10, 17 minus 5, 12. And beta 3 is nothing but the determinant of the matrix A. And determinant here will become first is 0, then minus 1 into 5, 9, 45 minus 45. That will be 0 plus 2 times 5, 3, 15 and minus 5, 6, 30. Okay, so 15 minus 30 minus 15 into 2 minus 30. This is the determinant and the beta 3. So what is the final characteristic equation? What is the final characteristic equation? It becomes lambda cube minus beta 1 lambda square, that is 15 lambda square, plus beta 2 lambda, that is plus 12 lambda, minus beta 3, that is minus of minus 30, becomes plus 30 equal to 0. So what is the characteristic equation of system then? The characteristic equation of system is identical to the characteristic equation of the matrix. So, in terms of S, you can write this as S cube minus 15S square plus 12S plus 30 equal to 0. Okay. Now, how many roots are in the RHP? It's a cubic equation. You don't have calculator, but you have RH. What you have is RH. S cube minus 15S square plus 12S plus 30 equal to 0. S cube and S square, first two rows applying the RH criteria. So 1 and 12 minus 15 and 30, sign change comes here only. S power 1 minus 15 into 12 minus 180 minus 30 minus 210 divide by minus 15. So minus minus plus. Okay, and then last element 0 of any row. S power 0, suppose this is x into 30 by x. So this is 30 and 0. How many sign changes occurred? Okay, 1 to minus 15 to 2. Okay, so 2 minus 15 to positive, some positive number. Okay, so 2 sign changes means 2 RHP. 2 sign changes means 2 RHP. The how many right half plane poles? Option number C. Option number C. Yes, correct answer, Sai Vikas. Yes, Charan Raj, that RH has to be applied. Next, if it is possible to transfer the system state xt naught to any desired state xt in specified finite time by a control vector ut, then the system is said to be what? If it is possible to transfer the system state xt naught to any desired state xt in specified finite time by a control vector ut, then the system is said to be what? The system is said to be controllable if you are able to control the entire state vector to This is known as the initial state. So transferring the system from initial state to any desired state, okay, in a finite time by the application of control. So system is completely state controllable. You are able to control every state. This is the definition. This is nothing but the definition of how a system being state controllable. Next question. Okay, whether the system is controllable or observable, a question for which we will apply generally the Kalman's test. Okay, right, x dot equal to ax plus bu, y equal to cx plus du. The question to check controllability, observability, will apply the Kalman's test. We will apply the Kalman's test. Yes, for the previous question, B was the answer. That was a definition. Now we'll apply the Kalman's test. Okay, for controllability and observability both. Okay, so what is the Kalman's controllability test? Okay, the first we form controllability matrix S. It's a second order system. So what is the second order system? B matrix. What is the S matrix? B and AB. Because generally the matrix goes to up to A power n minus 1. A power n minus 1 into B. B, AB, A square B, etc, etc, etc. But here, okay, if I want to write down the pattern, it is like this. Up to A power n minus 1 into B. These many matrices we write down together, augment together. But for n equal to 2, majority of your questions are, here with n equal to 2. Otherwise, the matrix calculation, matrix algebra becomes lengthy. Okay, so it is B and AB. Okay, what is the AB matrix? Okay, A and B are given. I'll multiply them individually. So A is 1, 1, minus 2, minus 1, 1, 1, minus 2, minus 1 into the B matrix is 0, 1. If I multiply 0 and 1, then second row 0 and minus 1. Okay, so what is the S matrix? I will rewrite. Okay, dear, what is my S matrix? The B matrix is 0, 1, and then this is 1 minus 1. And what is the determinant of S? Determinant becomes 0 minus 1, which is not equal to 0. And if this controllability matrix is non-singular, having non-zero determinant, then the system is controllable. Then the system is controllable. Then the system is controllable. Tell me if there is any doubts. Okay, then similarly, I will check for observability matrix. What is the observability matrix? It is written as C, CA, etc. up to CA power n minus 1. But again, for n equal to 2, the matrix is simply C and CA. And again, this should be non-singular for the system to be observable. For the system to be observable, this should be again non-singular. Yeah. Right. So let's complete the calculations then quickly. What is the CA matrix? What is the CA matrix? C is 1, 0. A matrix is 1, 1, minus 2, minus 1. This is first row, first column 1 and 0, only 1. Then 1 and 0, again 1. Okay. So what is going to be the V matrix then? Is the C and CA. C is 1, 0 and CA is 1, 1. Again, the determinant of V is 1 minus 0. 1 minus 0 not equal to 0. Non-zero determinant means observable. Kalman's test question. The system is what? Controllable only? No. Observable only? No. It is both controllable and observable. Option number C. Option number C. Yes, Sai Vikas says answer C. If you have given the answer C for this question, it is correct only. Correct. It is option number C. It is both controllable and observable. Okay. Now you see. What is the type of matrix given? Diagonal matrix. And diagonal matrix, because the matrix A is a diagonal matrix, that too, important point, diagonal matrix with non-repeated diagonal elements. Non-repeated diagonal elements confirms DCF. Okay, so what is given to you is a DCF model. And for DCF or JCF, you can apply still Kalman's. Previous method, you can cut, copy, paste and apply. But for DCF and JCF, there is the very, very simple test known as the Gilbert's test. Okay, which I will not cover in detail right now for this session. Okay, you can watch. I have taken sessions on controllability, observability. Okay, and I have taken in two different parts where I have in one of the parts I have only covered Kalman's test. In the second part I have covered Gilbert's test. It is available on the Om Institute YouTube channel also. Okay, so always be subscribed to the channel so that you know any of the content you get easily. Any past content, any future updates you'll get automatically. So, you know, controllability, observability, before the GATE exam I covered Gilbert's test separately, Kalman's test separately. Okay, I'll tell you the answer because Gilbert's test means observation. I don't have to calculate. Kalman's means I have to calculate. But yeah, previous question was not in any of the standard form. Okay. Even for Kalman's test, if the question is in OCF or CCF, Gilbert's test cannot be applied for OCF, CCF, but still there is a shortcut with respect to Kalman's test also. I have covered everything in my previous videos. Okay, that shortcut also for OCF and CCF. Okay, now it is DCF model, Gilbert's test. Now see, this particular element, okay, being 0 confirms not controllable, uncontrollable. And this element, both the elements, okay, every particular row of the B matrix corresponding to distinct eigenvalue should not have all 0 elements. Okay, it should not be full of row zeros. Okay, so this is a row of 0, uncontrollable. This is a column of 0, this is unobservable. Okay, you will only be able to understand this question if you know the Gilbert's test. If you don't know, you can watch my previous videos. That's what I'm telling. I will not be going into details of Gilbert's test right now because again, that will, you know, take a lot of time. Okay, so I've already made videos onto it. It is uncontrollable and unobservable, option number D. Okay. Next. This was 2021 question. Next, 2024. You see, EE 2024 question, 3 cross 3. If you think with respect to Kalman's test, solving a 3 cross 3 matrix problem will be lot of time consuming. Okay, not only time consuming, I'm repeating, lot of time consuming. But you see the type of matrix this time. Okay, the type of matrix you see this time is upper triangular. Upper triangular matrix, important point, with repeated eigenvalues, with repeated diagonal elements. Okay, confirms a JCF model. Okay, it is not only upper triangular, it should be upper triangular having some repeated eigenvalue or diagonal element. Okay, so that confirms JCF, and JCF also means Gilbert's can be applied. Here also Kalman's can be applied, but you should not apply. And for Gilbert's, okay, if both these elements, this should be don't care. Okay, this should be don't care whether it is 0, non-zero. But yes, both these elements, okay, both these elements, non-zero confirms controllability. This is non-zero. This also non-zero, confirms controllability. They have not asked observability because anyways for observability you have to, you know, have the C matrix, which is not given also. And with respect to Gilbert's test, this is don't care actually. The second and third element should be controllable, should be non-zero, which are non-zero, and hence the system is controllable. Answer is A. Answer is A. Yes, correct answer, Sai Vikas and Charan Raj. Okay, so again I'll suggest, if you don't know the Gilbert's test, you will have to go to watch the video so that you understand both these solutions. Okay, but you see recent years only. This was just previous years. Okay, on the Gilbert's test. In the GATE also these questions are very common. Okay, these are very common. And this was on DCF model 2021, and this is 2024 on the JCF model. Right. Right, guys. So if you or your friends are also planning, you know, for the preparation of AE exams, either Telangana Transco Discoms, AP Transco Discoms. Okay, so for any AE or AEE examination, the new batch started just May 13th. Okay, so you can visit our Hyderabad center, offline center, or you can contact 95156940053 for any details, or you can visit our website as well. With respect to GATE, already in the beginning I briefed you that yes, the summer short-term course, okay, starts on 18th May. And as well as the offline regular course, that means the long-term course also starts 18th May. The fees for both the respective programs along with special discount mentioned. So May 18th is approaching. In the beginning, I already told you the advantages of summer short-term. But yes, if you can be in Hyderabad for long-term, you can cover the entire syllabus in offline manner using our long-term course. Okay, using our long-term course. Okay, here you have complete offline from the beginning till the end. Here it's a 2 months program, and 2 months program means roughly 50 to 60% syllabus covered in offline manner. For remaining, you are given the online access, live and recorded. So you have the complete syllabus coverage, but around 60% in offline and rest in online. Okay, for which you will be given complimentary online access. You don't have to pay anything else. This is the fee for summer short-term course, 45,000, and this is the fee for the long-term course, that is 55,000. The respective discounts are mentioned. Okay, and in any case, you cannot travel to Hyderabad, okay, for any of the reasons, and you are confined, or if you are a college going student, of course, you cannot then directly come to, leave your college and come and stay to Hyderabad. So then, still, if you want the preparation under the best faculty team of ECEE, you can take our live courses, online live batch. Okay, for gate 26 with 1 month, 1 year validity is priced at 19,999, and for gate 27 long term with 2 years validity is priced at 28,999. Again, you can visit our website for more details or contact our support numbers to get any details about this. The faculty wise, it will be same. Whatever faculties we have, we'll cover both the courses, offline and online. That's what we assure you. Okay, so like the previous class, I think I forgot to share the previous class PDF. So today I will share both the PDFs. Okay, the previous control system part 1 and part 2 also. Okay, so for part 1 already I told you some password. Na? Today also we'll have some password. And what is the password? Last question was on JCF. Okay, because I told you only those who are interested in learning, those who are watching, those who are spending time, they only need the notes. If you have attended, you need the notes. That's what I believe. Okay, and that is why I keep a simple password. The password for this PDF will be JCF. For this particular today's PDF is JCF, everything in small. Last question we discussed JCF, so randomly. Okay, so JCF, everything in small. Thank you. Stay connected. I'll be sharing the PDF, both the PDF control system part 1, part 2 in this particular Telegram group. Okay, and then next, as I told you, first I'll prefer to take some, again, ESE PYQs only, but I'll take maths and then we'll go to signals. Like that, I'm trying to plan. Okay. So stay connected with the channel, stay subscribed so that the next information you get it. Also, the information about the session I'll share on the Telegram as well. Bye bye. Thank you.